Good morning, everybody. For this semester, in the topic of inorganic chemistry, we have three topics. In that, the first is the atomic structure. We are going to start with the atomic structure. Now, before going to the atomic structure, let's first see how the atomic structure were determined. That means how we go to the atomic scale first, that we will see, and then different theories for atomic structure we will see. So first, the classical mechanics. Now what is the classical mechanics? The classical mechanics is the mechanics or a theory which was proposed for the large or the macroscopic objects. The macroscopic objects like Earth, Moon, galaxies, the different everyday objects that we can see with our eyes. The behavior of all these large objects or the macroscopic objects was explained with the help of this theory. That theory is called as the classical mechanics. In this theory, or this theory constitutes of the laws and the different theories, the Newton's laws of motions and the Maxwell electromagnetism theory. This together forms the classical mechanics. That means that the behavior of the macroscopic objects is fitted in these laws and the theories. That means the Newton's laws of motion and the Maxwell's electromagnetism theory. The Newton's laws of motion, that is, first is the law of inertia, the law of action and reaction. These laws are the Newton's laws of motion. And the Maxwell electromagnetism theory, that Maxwell told that the light is traveling in the form of the waves, which is made up of the oscillators, and these oscillator in the sense which are vibrating, those vibrating materials are called as the oscillator, and this oscillator can take any continuous value of energy, and there is no need of medium for the propagation and traveling of the light. This was the Maxwell's electromagnetism theory. Till the 1900, all the objects which are large, that means the objects that we can see with the eye, for those all objects, their behavior was explained through this classical mechanical theory. But after 1900, the different phenomena were experimented, and in these experiments, the results those were obtained, those results were not explained with the help of the classical mechanical theory. The results those were very different than the different hypotheses of classical mechanical theory, and therefore from them the experiments those were done at the atomic and subatomic level. That means the particles or the objects which we cannot see even with the microscope. For such particles or for such objects, this classical mechanical theory was not applicable, and the experiments those were done at the atomic and subatomic level, that is at the micro level, and therefore from then a new theory was developed which is called as a quantum mechanics. And this quantum mechanics, this was developed up after 1900, that is in 1925, the different phenomena for the microscopic objects were explained, and that were coming under the quantum mechanics. That means that this classical mechanics, this theory is for the macroscopic objects, large objects, even a very large objects like Earth, galaxies and all. While the quantum mechanics, this is the theory for the particles which are a size of micro. The microscopic objects, the behavior of them is described, explained or studied in the quantum mechanics. Alright, so let's see how the classical mechanics or the first phenomenon that started the development of the quantum mechanics. The first phenomenon that we are going to see is black body radiation. This is the first phenomenon, the black body radiation. Now, let's first see what is a black body. Generally, if any object is incident with the light, some of the light is absorbed, some of the light is reflected, and some of the light is transmitted as it is. But if a body, for example, carbon black, or a metal surface which is painted with a black paint, such objects, when they are incident with the light, all the light energy is absorbed by such material. Such bodies are called as the black bodies. That means they are perfect absorbers. When the light radiations are incident on such matter, therefore all the radiations incident on it are absorbed. None is reflected, none is transmitted, only the light is absorbed. All the light is absorbed. Such bodies are called as the black bodies. And when such bodies are heated to certain temperature, therefore all the energy they had absorbed is emitted in the form of radiations of different wavelengths. Alright? That means these black bodies are perfect absorber as well as perfect emitter. When they are heated to certain temperature, all the energy it has absorbed, it gives out or radiate out in the form of the radiations of different wavelengths. Alright? Now, the different wavelengths which are given out by the black body, when it is plotted, this is how the graph we will get. We will get such a type of a graph. Alright? And this type of a graph, here certain temperatures are written. That means your black body is heated to this much temperature. Therefore, it is observed that when we heat the body at definite temperature, the radiations are emitted, and those emitted radiations have different wavelength and different energies. The radiations which are given out, they have different wavelength, and obviously as the wavelengths are different, the energy of them will also be different. This wasn't explained through the classical mechanics, because according to the classical mechanics, the radiations must be given of only single wavelength. क्लासिकल मेकॅनिक्स जे काही आहे त्यानं काय सांगितलं की हे जे काही रेडिएशन्स बाहेर पडतील हे रेडिएशन कुठल्या तरी एकाच सिंगल वेव्हलेंथचे असले पाहिजे. बट व्हेन इट इज एक्सपेरिमेंटली ऑब्झर्व्ड, एक्सपेरिमेंटली डन, therefore it is observed that the radiations are given out of which are of different wavelength, and the energy is distributed unevenly through these radiations. त्यांच्या वेव्हलेंथ वेगवेगळ्या आहेत, म्हणजे ऑब्वियसली त्यांच्या ज्या काही एनर्जीज आहेत त्या सुद्धा वेगवेगळ्या आहेत. Such curve is obtained. That means that the radiation at definite temperature, this curve we have seen. This curve shows that a radiation of a typical wavelength has highest intensity, while some lower and the higher wavelength radiation have lower intensity. A typical one wavelength radiation have highest intensity, and rest of the other wavelength will have lower intensity. This wasn't explained with the help of a classical mechanics. हे classical mechanics ला explain करता आलं नाही. This is what is the observation. आता आपण इथे जे काही वेगवेगळे कर्व्स आहेत प्रत्येकावरती टेम्परेचर लिहिलेलं आहे, आणि टेम्परेचर जे काही आहे जसं जसं आपण वाढत जातोय त्याप्रमाणे ज्याप्रमाणे तुमचं टेम्परेचर वाढेल ज्याप्रमाणे तुमचं टेम्परेचर वाढेल त्या प्रमाणात, आता पहा आपल्याला इथे सरळ सरळ पाहायला मिळते, पहा हा जो काही मॅक्सिमा आहे हा मॅक्सिमा लोअर वेव्हलेंथ कडे चालला आहे, म्हणजे थोडक्यात हायर फ्रिक्वेन्सीकडे. जसं जसं आपण डेफिनेट टेम्परेचरला हिटिंग करतोय, जो काही मॅक्सिमा आहे तो मॅक्सिमा लोअर वेव्हलेंथला शिफ्ट होत चालला आहे. That means that whenever you change the temperature of heating, the typical wavelength radiation with a maximum intensity shifts to the lower wavelength on increasing the temperature. जसं जसं आपण हीटिंग टेम्परेचर वाढवत जाऊ तसं तसं ज्या वेव्हलेंथ रेडिएशनला हायेस्ट इंटेन्सिटी आहे ती लोअर वेव्हलेंथ कडे शिफ्ट व्हायला लागते, बरोबर. सो हियर these facts which are observed here, जे आपल्याला इथे ग्राफ मध्ये सरळ सरळ दिसतात, these facts where the classical mechanical theory failed to explain these facts. Alright. Therefore, according to the classical mechanics, or in a classical mechanics, two theories were given, or the two laws were given to explain the maxima of the curve here. Therefore, this is the first law, that is the Weis radiation law. The law is 8 by hc by lambda raised to 5 into e raised to hc by kt lambda. That is the Weis radiation law. This is Rayleigh-Jeans law. These two laws, these were formed on the basis of a classical mechanics, and the Weis law is well applicable at the lower wavelengths, but it cannot explain the part of a curve on the higher wavelength. While this Rayleigh-Jeans law, which is also based on the classical mechanical theory, this law can also explain the part of a curve which is on the higher wavelength. It cannot explain the radiation or the wavelengths, their energy on the lower part of the wavelength. So these two laws, they fail to explain these curves or the black body radiations. Alright. Therefore, Max Planck gave a new law which is called as the Planck's radiation law. The E lambda is equal to 8 by hc by lambda raised to 4 into 1 upon minus hc by kt lambda minus 1. This is called as the Planck's radiation law. And through this law, complete curve was explained from at the lower wavelength also and at the higher wavelength also, and also the existence of the maximum, that means at the typical wavelength you get the maximum intensity of a radiation, that was also well explained in this Planck's radiation law. And in these two theories, these two laws are, these are based on the classical mechanics, which tells you that the matter or the light which is constituting of the vibrating material which is called as oscillator, that can take continuous values of energy, while Planck said that the oscillator or the light which is constituting of the oscillator, they can have only the fixed energies, they cannot have the arbitrary or the continuous values of energy, their energies are fixed. That is called as actually the quantum mechanics. Quanta, the quanta means a packet of energy. That means in a quantum mechanical theory, it is proposed that the objects are having the definite and the fixed energies. Any continuous value of energy they cannot have. It was proposed in the quantum mechanics, and this theory is applicable to the microscopic objects. The microscopic objects, their energy or their energy levels are having the fixed energies. Any continuous value of energy they cannot have. And therefore, this Planck's radiation law, here this is considered as a one constant. This, obviously 8 by hc one constant, and this hc is also a constant. This is termed to be c1 constant and this is c2. If the energy which is obtained for the lambda max, the energy highest, when this is substituted, therefore from from the graph, the value of a C1 and C2, these are the value of C1 and C2 which are obtained, and these are in a good agreement with the calculated value. आता हे जे काही कॉन्स्टंट्स आहेत त्यांची कॉन्स्टंट आपण h प्लस कॉन्स्टंट c वेलोसिटी ऑफ लाइट यांच्या व्हॅल्यूज टाकून आपण हे जर कॅल्क्युलेट केले तर यांच्या येणाऱ्या ह्या ज्या व्हॅल्यूज आहेत त्या व्हॅल्यूज आपण एक्सपेरिमेंटली येणारी जी काही एनर्जी आहे एनर्जी टाकली दी लॅम्बडा मॅक्स म्हणजे ज्या वेव्हलेंथला तुम्हाला मॅक्सिमम इंटेन्सिटी मिळते तो लॅम्बडा टाकला, या सगळ्या जर व्हॅल्यू टाकल्या, टेम्परेचर टाकले इथे केटी लॅम्बडा आहे पहा, या जर व्हॅल्यूज टाकल्या तर आपल्याला C1 आणि C2 हे जे काही कॉन्स्टंट्स या लॉने मिळतात, दोज आर इन अ गुड ॲग्रीमेंट विथ द कॅल्क्युलेटेड व्हॅल्यू. कॅल्क्युलेटेड व्हॅल्यूशी या व्हॅल्यू मॅच करतात, याचाच अर्थ हा जो काही लॉ आहे इट कॅन एक्सप्लेन दीज कर्व्स वेल. आता हे कर्व्स एक्सप्लेन करताना सगळ्यात पहिलं महत्त्वाचं म्हणजे दी एनर्जी विच इज रेडिएटेड और एमिटेड it is not evenly distributed between all the wavelengths. वेगवेगळ्या वेव्हलेंथ बाहेर पडतात पण या सगळ्यांची एनर्जी मात्र सारखी नाही. सेकंड ऑब्झर्वेशन, there is a maxima obtained where a typical wavelength radiation is having highest intensity or highest energy. Rest of the wavelength will have lower intensity. This is the second observation. The third observation is that whenever you increase the temperature of heating, the maxima, that means the lambda max, that shifts to the lower wavelength. Lower wavelength ला हे maxima shift होताना दिसतात. हे पहा, या बाजूला तुमचे जे काही मॅक्सिमा आहे इथपासून आपण सुरुवात केली, इथे मॅक्सिमा, त्याच्यानंतर हा आणि त्याच्यानंतर हा, म्हणजे तुमचे मॅक्सिमा लोअर वेव्हलेंथला सरकत चालले. हे जे काही मॅक्सिमा आहे दीज आर डिपेंडिंग ऑन द हिटिंग टेम्परेचर अँड नॉट द मटेरियल. मटेरियल कुठल्या कंपोनंट्सचं बनलेलं आहे याच्यावरती हा मॅक्सिमा डिपेंड नाही, तुम्ही किती टेम्परेचरला तुमचं ब्लॅक बॉडी हीट करताय त्याच्यावरती हा मॅक्सिमा डिपेंड असेल. सो दीज आर द मेन observations of black body radiation, and these observations were not explained with the help of classical mechanics. Classical mechanics failed to explain these observations. Now, as I told you that in the classical mechanics it is proposed that the oscillators can have any continuous energy value, पण प्लँकने मात्र सांगितलं हे जे काही मायक्रोस्कोपिक ऑब्जेक्ट आहेत यांच्या मात्र आर्बिट्ररी कुठल्याही एनर्जीच्या व्हॅल्यू असू शकत नाही. याच्यासाठी एक सिंपल एक्झाम्पल आहे का, हे पहा, सपोज वी वॉन्ट टू गो फ्रॉम हियर टू हियर, ऑलराइट, टू वेज आर देयर. दिस इज वन वे and another way is this. The twin steps are there. Like this. Therefore, this is one way, this is another way. While going from by this ramp, we can step at anywhere. आपण कुठेही पाऊल ठेवू शकतो आणि कुठेही थांबू शकतो, बरोबर. हे रॅम्प सारखं आहे, म्हणजे याचा अर्थ इथून जाताना आपल्याला कुठेही थांबता येईल, कुठेही पाय ठेवता येईल. पण जर स्टेप्स वरून आपल्याला जायचं असेल तर डिरेक्टली वी हॅव टू स्टेप ॲट द स्टेप्स. स्टेप्स वरती पाय ठेवावे लागतील आणि मगच इथे जाता येईल, बरोबर. म्हणजे याचा अर्थ समजा इथे असं कन्सिडर करा की ह्या इलेक्ट्रॉनिक एनर्जी लेवल आहे. म्हणजे समजा जर इलेक्ट्रॉन इथं असेल तर इलेक्ट्रॉनला जर इथून इथं जायचं असेल तर या दोन एनर्जी मधला जेवढा एक्झॅक्ट गॅप असेल तेवढीच एनर्जी इलेक्ट्रॉनला घेऊन इथं जाता येईल. त्याच्यापेक्षा जर एनर्जी इलेक्ट्रॉनला कमी मिळाली तर तो काय करेल, इलेक्ट्रॉनला इतकी एनर्जी मिळाली की तो वरती जाईल, जेवढी एनर्जी मिळाली तेवढी. जर इथपर्यंत गेला नाही तर मध्येच कुठेतरी थांबलेलं पुन्हा याच्यात येऊन पडेल. आणि जी काही एनर्जी त्यांनी घेतली होती ती सगळी देऊन टाकली. दिस इज कॉल्ड ॲज द कन्सेप्ट ऑफ क्वांटा. म्हणजे इथून इथे जाण्यासाठी आपल्याला एक्झॅक्टली या दोन याच्यात एनर्जी एवढा जेवढा गॅप असेल तेवढा गॅप एवढी एनर्जी इलेक्ट्रॉननी घेतल्याशिवाय त्याला वरच्या स्टेप्सला जाता येणार नाही, म्हणजे वरच्या एनर्जी लेवलला जाता येणार नाही. तसंच आपल्याला इथून डायरेक्ट इथे पाय ठेवावा लागेल. वी कॅनॉट स्टँड इन बिटवीन. इथं मध्ये आपल्याला उभं राहता येणार नाही. म्हणजे हा जो काही वे आहे हा कसा आहे, डिसकंटिन्युअस. The way of climbing this is discontinuous way, because here we cannot stand, we have to stand on the steps, while this is a continuous way. आपल्याला सलग कुठेही पाय ठेवता येईल, कुठेही थांबता येईल. दिस इज नॉट पॉसिबल हियर अँड दिस एक्सप्लेन्स द क्वांटम मेकॅनिक्स. हा जो पार्ट आहे हा क्वांटम मेकॅनिक्स एक्सप्लेन करतो की ज्या काही एनर्जी लेवल्स असतात किंवा पार्टिकल्सच्या ज्या काही एनर्जीज आहेत त्या फिक्स असतात. म्हणजे समजा इलेक्ट्रॉन या लेवलवर असेल तर ही जी काही एनर्जी लेवल आहे हिची एनर्जी जेवढी आहे एक्झॅक्ट तेवढीच एनर्जी जर इलेक्ट्रॉनकडे असेल तर त्याला या एनर्जी लेवलमध्ये राहता येईल, किंवा त्याला या एनर्जी लेवलमधून वरच्या एनर्जी लेवलमध्ये जायचं असेल तर हा गॅप जेवढा आहे तो गॅप एवढी एनर्जी घेतल्याशिवाय तो वरती जाऊ शकत नाही. त्यानं जर निम्मीच एनर्जी घेतली तर तो इथे मध्ये कुठेही राहू शकत नाही. सो दीज आर डिसकंटिन्युअस वेज or this discontinue way of climbing. स्टेप्स वरती जावं लागेल. दोन स्टेप्स मधला जो स्टेप आहे that is a discontinuity. Here is a continuous way. म्हणजे इथे पार्टिकल्सला कुठलीही एनर्जी घेऊन हळूहळू वरती जशी अमाऊंटची एनर्जी वेगवेगळ्या अमाऊंटची एनर्जी घेऊन वरती जाता येईल, इथे मात्र फिक्स अमाऊंट ऑफ एनर्जी घेतल्याशिवाय वरती जाता येणार नाही. सो दिस इज अ डिसकंटिन्युअस वे. म्हणजे याचा अर्थ मायक्रोस्कोपिक ऑब्जेक्टच्या एनर्जीज या डिसकंटिन्युअस आणि फिक्स्ड सर्टन एनर्जीज असतात. वाईल in a classical mechanics the objects can have continuous any energy. कुठलीही एनर्जी ऑब्जेक्ट्सला असू शकते. So this is the difference between quantum mechanics and classical mechanics. And the first phenomenon, black body radiation, which actually ज्या फिनॉमिनामुळे क्वांटम मेकॅनिक्स ही ब्रांच अस्तित्वात आली तो हा फिनॉमिनन आहे. दॅट इज द ब्लॅक बॉडी रेडिएशन. कारण इथून फिक्स्ड एनर्जीचा जो काही कन्सेप्ट आहे दॅट कन्सेप्ट हा स्टार्टेड. इथून हा कन्सेप्ट फिक्स्ड एनर्जीचा कन्सेप्ट सुरू झाला. राईट. वन मोर फिनॉमिना, the second phenomena, that is a photoelectric effect, we will see next time.